geometry is built on 3 basic undefined terms. That's what they're called. And that's points, lines, and planes. Okay? We would say they're undefined terms because for the most part, we all know what a point is, what a line is, and what a plane is. And then after today, we're going to build things with these. And come, I don't know, October, we're going to make shapes with points, lines, and planes. And then come April, we're going to make 3D figures with points, lines, and planes. Okay, but we're going to start at the most basic level first. Before we can get to those, we have to know what space is. And space is defined as the set of all points. So this classroom, space, it's the set of all points. There's a ton of points in space. That's where your points and your lines and your planes lie. They lie in space. BUT, that just stands for basic undefined terms. We call them BUT terms. Okay. The first one, a point, is defined as a location in space. It has no size. There's no dimension to it. When you see points in your diagrams, in your textbooks, worksheets, they are named by using a capital letter. Uppercase letter, capital letter. So on the smartboard, we have point A. On my front whiteboard, there's point E. Sideboard, we got point W, the location in space. Here's point X, up there. We could say the decimal point and pi back there. It's a point in space. This point right here on the top of Brady's head, his hair, that's a point in space. Quit moving, you're moving my point, okay? Point in space, any location. The top of Veronica's pencil, her eraser, that's a point. It's a point in space. Top of my pen, point in space. Okay, the tip of your nose, it's a point. It's a location in space. There are an infinite amount of points in space. What does the word infinite mean? Never ending, yeah, like Buzz Lightyear, to infinity and beyond, right? Yeah, okay. A line is your second term. It is a series of points that extend in 2 opposite directions without end. Without end means it goes on forever. A line goes in both directions forever. It's a series of points. So I have 3 points here, W, I, and L. There's an infinite amount of points in space, so there's actually like more points in between them. And there's more points in between those ones. And there's even more points in between those ones. And there's so many that are so close together that when you look at them like that, what do they create? A line. And lines go on forever in both directions. That's what the arrows mean. It's going that way forever, and it's going that way forever. Lines go on forever. Okay. Your last one, a plane. A plane is a flat surface. It has no thickness. And it contains many lines and points. And it goes in all directions forever. Plane, flat surface, has points and lines on it, and it goes in every direction forever. Can't draw that on a paper because I don't have paper that goes on forever. But most of the time, your plane's going to be represented by this tilted rectangle. The ceiling, that's a plane. It's a flat surface. Your desktop, it's a plane. It's a flat surface. The tabletop, flat surface. The whiteboard, it's a plane. It's a flat surface. There are points on planes, and there are lines on planes. If there's points on them, there's lines on them. The ceiling, all the ceiling dividers, lines running on the plane. The wall, all the divisions and the bricks, those are lines. Okay? Planes go on forever. Lines go on forever. Those are your three terms. You can build a lot of things with those three terms. Collinear points. Collinear. In Spanish, the word co means with, together. And then you have another word here, L-I-N-E, which is what? Line. Points with the line. Collinear points are points on the same line. Collinear points are points that lie on the same line. All these points here, W, X, T, R, I, P, S, Y, L, collinear. They're all on the same line. Points that are not on the same line, E, W, and L, I cannot connect E, W, and L with one straight line, are called non-collinear. Non-collinear points, not on the same line. Line W, or excuse me, point W, point E, and point, I have two W's, L, would be non-collinear. There's not one line, not one piece of string that would stay straight that would connect W over there to L and E over here. Non-collinear. If collinear means on the same line, what do you think coplanar means? On the same plane. Coplanar points are points that lie on the same plane. You can have coplanar lines also. You can have lines that are on the same plane, like all the dividers on the ceiling. Those are coplanar lines. The speaker is a point. The sprinkler is a point. That speaker is a point. Those 3 points, coplanar. They're all on the same plane. Would those 3 points be collinear? No, I can't connect that speaker to that speaker with that sprinkler with one straight line. It'd be curvy, which would no longer make it a line, or you'd have to take 2 lines. Okay? Coplanar, on the same plane. Collinear, on the same line. We're going to skip that fill in the blank. It's weird. Postulate. You see the word postulate? In geometry, you have a ton of postulates. A postulate is just a funky word for rule. A postulate is a rule that you must follow in geometry. Euclid, a guy named Euclid, he came up with all these rules. Okay? By definition, a postulate is accepted without proof. Meaning, I'm going to tell you this rule. I do not have to explain it to you. You just accept it. Postulate needs no proof. It needs no explanation. It just is. We will go through 4 postulates today, 4 rules today, and we'll go through more on Monday and more and more and more and more and more. There are a lot of postulates in geometry, a lot of rules you have to follow. You should have a little rectangular box there, and that's where the 4 are. The first one, postulate 1-1. Through any 2 points, there is exactly 1 line. Through any 2 points, there is exactly 1 line. Point E, point W. 2 points, right? Which means I can make 1 line through them. There is no other line that exists through those 2 points. Through any 2 points, exactly 1 line. E and I. There is only 1 line that will connect E to I, no other. So your first postulate is telling you, if you have 2 points, you get 1 line and only 1 line. Right? Point Y and point W over there, 2 points, I can connect them with a line. If I had a piece of string, there'd only be 1 piece of string that would connect those straight. Okay? 2 points make 1 line. Your little fill in the blank here. Line T is the only line that passes through which 2 points? A and B. I cannot make line S to go through the same 2 points. There's only one line through 2 points, excuse me. All right, second rule, second postulate. If 2 lines intersect, they cross each other, then we call their intersection a point. If 2 lines intersect, they intersect at 1 point. Like right here, line WE and line IE intersect at point E. They're not going to touch each other any other time. They're only going to touch each other once. 2 lines, if they intersect, will intersect in a point. Do they have to intersect? No. What do you call 2 lines that don't intersect? Parallel, right? Yeah, good. So if 2 lines intersect, then their intersection is a point. In this case, what's the name of our intersection? C. And you can just write at C. 1 capital letter indicates a point. 2 capital letters with a line over it, that means line. 1 point, 2 line. Okay, so 2 points make a line. If 2 lines intersect, they intersect in a point. Rule number 3. If 2 planes intersect, then their intersection is 1 line. A plane, a flat surface. Oh, I don't know, like the ceiling, that's a plane. And the sidewall is a plane. Where they intersect, where they meet, is all along that line. 2 planes intersect in a line. This plane, the sidewall, and the back wall intersect along this vertical line here, this corner of the room. 2 planes will intersect in 1 line. If 2 planes intersect, then they're going to intersect on a line. So in your diagram there, plane RST and plane STW intersect on what line? ST. It takes 2 points to name a line. So plane RST, that'd be this guy, and STW intersect on line ST. Make sure you put the symbol above it, so I know that you're talking about line ST. All right, fourth rule, fourth postulate. Through any 3 non-collinear points, so 3 points not on the same line, there's 1 plane. The 2 speakers in the sprinkler, remember they were non-collinear? There's only 1 plane that they're all going to sit on, and that's the ceiling. Okay. WI and L, no, just kidding, WI and E, non-collinear, 1 plane, the front whiteboard. 3 non-collinear points make 1 plane. Like the clock and the home plate plaque that's sitting up there. And the, I don't know what else. Well, I guess this plaque too. There's not 1 line that's going to connect all 3 of those perfectly. So we would say they're non-collinear. So they have 1 plane, this wall. 3 non-collinear points make 1 plane. You have to know those rules. Make sure you read through them. We're going to use them through the examples now. So we're going to go down to number 1. It says in the figure, name 3 points that are collinear and 3 points that are not collinear, or they're non-collinear. So we need 3 collinear points, and then you need to find 3 non-collinear points. Dylan, what's it mean to be collinear again? Yeah, you got to be on the same line. So you're trying to find 3 points that are on the same straight line. Sydney, what do you think? Exactly, Z, Y, and W. Z, Y, and W are all on that horizontal line. It doesn't look like it, but Z, Y, W, and X, those are capital letters. M is a lowercase letter. If it's a lowercase letter, not a point. This is actually the name of the line. This would be called line M. So if it's a lowercase letter, then it's a line, not a point. Okay, those are the only collinear points there. Those are the only 3 points that are on the same line. They asked us to find 3 non-collinear points also. Emma, do you have 3 points that are not on the same line?
Would it be like Z, X, and W?
Yeah, Z, X, and W, definitely not on the same line. Shy, do you have a different set of non-collinear points? You had those ones too, Morgan?
X, Y, and W.
Yeah, X, Y, and W, those would be non-collinear. X, Y, and W are not on the same one. Are there any other sets that are non-collinear? Clean? Yeah, X, Z, Y. The 3 that make the triangle. Those are non-collinear. There's not one line that all 3 of them can sit on. Good. So sometimes there's only one answer. Those are the only 3 points that are on the same line. Sometimes there's more than one. Collinear, same line. Non-collinear, not on the same line. Number 2, you can name a plane using any 3 or more points that are on that plane. They want us to name this plane in more than one way. Okay. It takes at least 3 points to name a plane. 2 points to name a line, 3 points to name a plane. You can use 3 or more depending on how big the plane is. Okay. One name for this plane. SRUT. Nope, because it's not a line, it's a plane. You just put the capital letter. When you name a point, like we did on number 1, you don't put any symbol with it. You just write the capital letter. When you are naming a plane, you need no symbol with it. You just need at least 3 capital letters, if not 4. What's a different name for the plane, Sarah? TURS. Jason, you got a different name? RUST. Wouldn't that be great if it would work? You want to know why I wouldn't want this one? Didn't go in order. Good. It makes a nice word, which would be easier, but RUST, I'm jumping back and forth. When you name a plane, you got to go in order. You either can go clockwise or you can go counterclockwise, but just make sure you go in order. Thanks, though. Do you want to name it something else? Oh, Tyler, you have a name? UTSR. That's a name. We could name it RUT. You can use 3 letters. Just stop there. Tyler. TSR. 3 or more. You have to have 3. You can have more. Make sure you either go clockwise or counterclockwise. Don't skip around. URST would work also. Yep. There's multiple names for the plane. All right. Flip it over. Okay, we have a cube here, but you remember you have to think. Planes go on forever, so even though they're drawn here to stop and make this nice cube, they really are going on forever. First question at the top says, what is the intersection of plane HGC and plane AED? Well, you have to identify those planes first. So plane HGC, would we say that's the top of the box, the front, the back, the left, the right? It's in the back? Okay, I'm going to shade it in. It could, depending on how you're looking at it. Yeah, I agree. Okay, how about plane AED? What part is that? Which side? The lateral left side over here? So we have to figure out where these two planes intersect. What they have in common. An intersection is where they touch. What things do they have in common? Tyler. Oh, okay, hang on. Hold on to that question. Sarah. F? Well, I think F is right here. F's in the front. D. Okay, I agree. They have point D in common. Is that the only thing they have in common? They have H in common too? Or just those 2 points are the only thing they have in common? Wouldn't they have this point in common? The whole line. Good. 2 planes intersect at a what? A line. So my intersection for these 2 planes is line HD. Line HD. When you name a line, pick 2 points on it, put the symbol over it. Tyler, what was your question?
Okay, so this is in relativity to how, like, okay, you said that the plane's go on forever,
Right.
right? If we could see the plane going on forever, would the cube constantly be in proportion, or would it be not in proportion because they're constantly moving?
Well, if they're moving at the same rate, it would be in proportion. Do you agree? Okay, all right. We're going to skip that paragraph thing, and we're just going to go to number 4. So number 4, part A says to shade in the plane that contains x, y, and z. Shade the plane that has points x, y, and z. X, y, and z. Find that plane. Make sure you stay in the lines. Here's x, here's y, here's z. You shade everything on their plane. You should have shaded that back triangle there. Part B for this diagram are points W, Y, and X collinear. No, definitely not. I cannot draw a straight line that's going to connect W, X, and Y. Are they collinear? No. Cool, number 5. Using the picture, do you see it? It's to the right of number 4. Name line M in 3 different ways. Okay? One way to name lines, if the lowercase letter is there, is to just use the lowercase letter, which is what they did here. We have lowercase m, so they named line M using that. Why isn't this working? There's line M. Okay. We need to name that line 3 different ways. Can't really tell anymore since I made that bold. Point E is right there. It's where those lines intersect. Point F, you could see that point there. And then point C, I didn't actually draw the little circle, but it's where they intersect. Because remember, 2 lines intersect in 1 point. I have to come up with 3 other names for line M. How many points does it take to make a line? 2. 2 points to make a line. So that means I only need to pick 2 points on that line. What's 1 point on line M? What's another one? There we go. There's one name. Line EF. Don't forget to put the symbol over it. Okay, I need a different name. Colleen? Right. Yes. Pick a different point on the line. FC, there you go. Line FC. 2 points on the line. Sarah? Nope, only 2 points to name lines. Only 2 points to name lines. 3 points are for planes. 2 points. I'm missing one. Got EF. EF and FE are the same thing. EC, yep. They don't have to be right next to each other, the points. They don't have to be consecutive points. You can pick any 2 points on there. If I said CE, it's the same line. The order doesn't matter when you're naming lines. Gentlemen? Are we focusing? Thanks. Okay. Second part. Why do you think the arrowheads are used when drawing a line or containing a line, or excuse me, naming a line is necessary? Why do we put the arrows on the lines? What do you mean? How do you mean it's a line? What makes a line and not a segment? The liney things, the arrows. But what do the arrows mean? It goes on forever. Good. Why do we put the arrows on there? To indicate that it goes on forever, that it's a line. Lines and planes go on forever. The arrows tell us it goes on forever. So you can use the lowercase letters, if they're there, they're not always there, to name lines. Otherwise, you have to pick 2 points on it. To name a plane, we already did that in the front side. You pick 3, at least 3 letters, if not 4, to name the plane. Another way you can name planes, if it works, is if there's a capital letter on the plane with no point beside it. So if you look at the picture, you see how Z is floating there and there's no point? Then I can name this plane Z, which is what they did in the directions. There's no point next to it, so that's the name of the plane. If I have that, I can't call that plane A, because that's a point. Make sense? Okay, we need to name this plane 3 different ways, besides calling it plane Z. Maddie, what do you think? That's one name. EHG, good. There's one name. Veronica. Different one. GFE, good. Riley, what's the third name? HG for the plane. How many points does it name? HGF. Oh, it is? I guess I didn't really hear you. You'll have to enunciate better next time for me. Enunciate, speak up. Don't mumble. Do you know what mumble means? It's the opposite of enunciate. The opposite of mumbling. Tyler. FEH, yeah. I'm not going to write them all down, sorry. Thank you for volunteering, though. You could name this EFG, oh, that's a G, GH. You can use 4, but you have to have a minimum of 3. Right, Riley? Because 2 names a what? A line. 2 is a line, 3 is a plane. All right, number 7. Name the 2 planes that intersect on line BF. You have to find the 2 planes and name them that intersect on that line. Go ahead and do this here for a second on your own. If it helps first to like shade them in, like if it's the back or the front or the left or the right or the top or the bottom, and then go back and name them, then do it. Unlike algebra, geometry is going to have a lot of shapes and points and lines. Color the pictures if you need to. Draw on them, mark them up. You have to find the planes that are touching that line. Yeah. That would be the back side of it. What, you shaded in the right side, what letters are enclosing the right side? That's the name of that plane then. All right, so if you shade in the 2 planes, that blue line there is hitting the right side of the box and the front. So those would be your 2 planes of intersection. How would you name this front plane? What page? Yeah, EAB, that would be your name for it. So there's your front one, and then it's hitting the right side. Sydney, what would you name this right side over here? Yeah, GCB, good. And if you threw F on both of those, then that's great. You can use 4 letters, you don't have to. No, because it's not a line, it's a plane. Lines get lines above them. All right, we're going to skip 8. We're going to do 9. Part A says to name 3 collinear points, looking at that diagram to the right. Check out the diagram to the right and name 3 collinear points. Emily, did you get them? What did you come up with? 3. Can you find 3 collinear points? Name 3 collinear points. You have to find 3 points that what's collinear mean again?
2 points that are on the line.
They're on the same line, but I don't want 2, I want
3.
so find 3 points in the picture that all sit on the same line. So B and C, they only have 2 on that line.
C, G.
Okay, is G on the same line as these 2? If I extend this line out, will I ever hit? Okay.
I don't know.
Okay. Do you see 3 points on this line? Do you see 3 points on this line? Do you see 3 points on this line?
Is it just the line?
But I want points. So I only have point A and D right here, right?
Oh, D, G, J.
There you go, D, J, H. Good. Does that make sense? Okay. 3 points on the same line, D, J, and H. Those are the only, or that's the only answer here for number 1. Make sure you put commas between them. When you're listing points, you have to separate them with a comma. If you smash that together, I'm going to think it's a plane. Okay, so put your commas between your points. B, name 2 different planes that contain points C and G. So we have to find 2 planes that have C and G on them at the same time. 2 parts of the cube that hit those 2 points at the same time. Sarah? Okay. Brady, do you have any idea what plane hits those 2 points at the same time? You can use like top, bottom, left, right if you want to, for now. Oh, you do? You all do? Oh, geez, Louise, I'm sorry. The top one's supposed to be an F. Paige, do you know which 2 planes have C and G? B, C, G, F. Good, that'd be the top of it. So there's 1 plane. Now I need another plane that uses those 2 points. What? DCGH, that'd be your front. DCGH, that one has those 2 points at the same time. Good. All right, part C. Name the intersection of plane AED and plane HEG. 2 planes, if they intersect, will intersect at a what? A line. Your answer better be a line. So you have to figure out the line that these 2 planes are intersecting, where they meet. Shade the planes in. That's the same plane. That's the same plane. Yep. Yes, exactly. Then, what plane, what part of the box is plane AED? Like, is it the top, bottom, left, right, front, back? AED. Here's A, Ben. Here's E. Here's D. Good. All right, Ben. How about HEG? What side of the box is that one? That would be the right side. Mason, where does the bottom and the right side meet? Good, line EH. Two planes, if they intersect, will intersect on a line. So line EH, or HE, it's the same line. All right, last one here, D. How many planes contain points A, F, and H? Here's A, way down here. Grady, F is that top one, and H is down in the bottom corner. We have to figure out how many planes, how many flat surfaces contain those 3 points. Zero, 1, 2, 17, 38, 100.
I'm going to interrupt in the middle of classes.
One.
Just quickly.
One plane contains them.
We have a whole
Here's
bunch of
F,
comments here, but teachers, most
A,
importantly for you,
H.
please email me,
See this plane, this flat surface?
Extra desk, or if you have
It's touching
extra desk,
A
this thing
and H
called today,
and F up here.
Buy some more or whatever. So if you need extra desk,
3 non-collinear points.
or tools, or if you
None of these points are on the same line. Make one plane. So your answer here should be 1.
We have changes on that ACT thing, so you need to come in and give us
3 non-collinear points make one plane. Here's your homework.